topic of this video is graphing transformation techniques, vertical and horizontal shifts. Alright, let's look at a problem. Write the equation of the function that matches the graph. And this is the picture that we're provided with. Now, in order to be able to answer a question like this, we have to know our library functions, our basic functions, very, very well. So well that we recognize this picture. This picture looks a lot like the reciprocal function. Let me just create a quick sketch of the reciprocal function for you. The reciprocal function is the one that has these two wings in it, where in the quadrant 1, we have this curve, and in quadrant 3, we have this curve. And we note that the reciprocal function has asymptotes sitting right on top of the x-axis and right on top of the y-axis. So this function right here, which we recall has the equation f of x equals 1 over x, is very, very similar to what we see here. The only difference is this graph is missing the asymptotes, and it doesn't appear to be in the correct location. So let's put the asymptotes in, because I think that's going to help us solve this problem. So the asymptotes belong right here. At a height of 3, and right here, which is the normal place. Okay, so these graphs are identical with one exception. If you take the reciprocal function and you move it up 3 steps, you get this picture. Notice the location where the two asymptotes cross. It's at the origin. Notice the location where the two asymptotes cross in this problem. It's at 0, 3. Which means the y value changed from 0 to 3. That represents a shift up 3 spaces. Shift up 3. So it's a shift, it's up, which makes it vertical. Vertical shifts behave exactly the way you would expect, and so we just have to add 3 at the end of this equation. So our answer is g of x equals 1 over x, and then after that, plus 3. That is the equation that goes with this graph.